When you have an equation like this one here, um, it can define y as a function of x, but only implicitly. It would be very hard to find a formula for f of x explicitly. But there is a trick for finding the derivative of y with respect to x very easily. And that's what we call implicit differentiation. So let's generalize the problem to that of finding f of xy equals c. All right. So if we assume that y is also a function of x, then we have a chain rule situation. F depends on x and on y, and y depends on x. So we can differentiate both sides of our original equation. Oops. All right. And then from there, on the left side, we apply the chain rule. Well, there are two paths to get from f to x. So we write down everything along each path and add them up using partial derivatives where the variable has more than one dependency. So that's the left-hand side. The right-hand side is the derivative of a constant, so it's 0. And then it's very easy to solve for dy dx. It's just move the df dx over to the other side and divide. Okay, so that's one case. Another case is, let's say we have 3 variables. So that's a single equation in 3 variables implicitly defines a surface. Okay, so we could think of this as implicitly defining the surface z of xy. So that means that f depends directly on x and on y and on z. Z in turn depends on x and y. All right, so I have 2 paths to get from f to x. I have the top branch here, and then I have the bottom followed by the top there. So that means in order to get the x derivative on the left-hand side, I follow the top branch to get partial of f with respect to x. I follow the bottom branch to get partial of f with respect to z. And then I finish by going from z to x. So that's the partial derivative of z with respect to x. And that's equal to the derivative of c with respect to x, which is 0. Okay? Or I could start with the original equation and differentiate both sides with respect to y. So again, I have 2 paths from f to y. So I have the direct path, and then I have the path that goes through z. So partial of f with respect to z times partial of z with respect to y equals 0. Okay, and so both of these are, again, very easy equations that we can solve for the partial derivatives of z. And we can do this even if we don't know what z is explicitly as a function of f and y, x and y.